Dear friends, very good morning to all of you. The topic that we will be discussing today is about the Permian Triassic boundary. Permian Triassic boundary is the boundary between the end of Permian and the beginning of Triassic. Before we discuss about the paleontological consequences of this boundary and the events happened at that time, it is very essential to define a boundary. Boundaries are very complicated everywhere, be it a political boundary, maybe the boundary of your house and that of your neighbor's house. That means wherever there is a boundary, there is a problem. Yes, there are boundaries if they are natural, they are free of any complications. But whenever these boundaries are defined by man, when they are man-made, then it is not as simple as we conceive. And it is the boundary in terms of the geological history of Earth. If we see, the boundaries, they define different zones or time lines, especially if you talk about Phanerozoic. Paleontology mostly concerns Phanerozoic. Why? Because it was the time many of the forms were evolved and they diversified, even they become extinct. So, these events that happen on the surface of Earth and they are having a huge time span. So, they are very important when defining the boundary of one particular time and one particular event to the other. That means, when one system with its own consequences, with its own faunal assemblage shifts and another ecosystem is formed, another set of consequences they develop. So, these two different domains, they have different attributes, and the boundary between these two domains, they are very important. It is important and at the same time it is unreal. Why? Because we arbitrarily define that boundary, not that the boundary strictly exists in that nature. The Phanerozoic, as you all know, has been divided into three components: Paleozoic, Mesozoic and Cenozoic. It is very interesting to note that the Paleozoic and Mesozoic boundary has been kept at Permian Triassic transition, and this is something about 251 million years or something. So, that 251 million years that define the boundary between Paleozoic and Mesozoic, and this boundary is the boundary in which the 95% of the Earth's life became extinct. That means, this happens to be a big catastrophe. In fact, this catastrophe and this shift over on a big scale of the Earth, that is something which defines the particular boundary between Paleozoic and Mesozoic. Similar is the boundary between Cenozoic and the Mesozoic. Mesozoic Cenozoic boundary is essentially the Cretaceous tertiary boundary, and in that boundary also we find a big earth scale mass extinction, that is called as KT boundary mass extinction. We have already discussed about the KT boundary mass extinction in the separate lecture. And in this KT boundary, you had extinctions, but these extinctions they were mostly on the land animals. The Permian Triassic, that is the first extinction between Paleozoic and Mesozoic, that happened in the marine as well as in the terrestrial realm. Rather, the marine realm has been more affected than the terrestrial realm. So, these are the two major global events, that is Permian Triassic boundary defining the boundary between Paleozoic and Mesozoic, and second is the Cretaceous tertiary boundary mass extinction that defines the boundary between Mesozoic and Cenozoic. We see that these global events on the scale of Earth, they help to slice the Earth's history into several domains. But the point comes, how do we define that boundary? The Webster's definition says that anything that defines limit is a boundary. That is a very simple definition of a boundary. But especially concerning the today's topic, that is Permian Triassic boundary. So, the Permian Triassic boundary has to be the boundary at the end of the Permian or the beginning of the Triassic. So, end of the Permian and beginning of the Triassic is not just one time everywhere, it is time transgressive. That means we identify the end of the Permian by the extinction of some particular form, or the beginning of the Triassic by the appearance of a new form. So, that disappearance or the last appearance of a particular life form or a taxa and the first appearance of the new taxa, this appearance, disappearance and reappearance is not same on the earth's surface of the Permian Triassic rocks found in India, and they are found in the sections exposed elsewhere. That means these events, they are not uniform, rather they are diachronous. That means the system was time transgressive essentially. That means we have to identify the features which is common in every section. In all the exposed sections, we must identify either the same feature which is common, or the features which are about approximately common. Then a particular time or a particular event will be identified that can demarcate the Permian Triassic boundary. The best exposed section of the Permian Triassic boundary is in Mishan section, China. In India, it is exposed in the Gour ravine. There are some other sections even in the Europe also. We have the Permian Triassic boundary sections exposed. It is exposed in the Iran. So, there are many places in which the Permian Triassic boundary stratotype sections are exposed. But let us first decide what is this Permian and Triassic. Actually, the Permian is named after a place in Russia called as Perm. So, the isochronous rocks of the rocks exposed around Perm worldwide have been called as of Permian, and they are defined by some very specific paleontological assemblage, and we get the similar assemblage elsewhere worldwide. So, that approximately defines a particular time zone, and that is what we call as Permian. Similarly, the type section of the Triassic is in Europe, defined by three local names: Bunter, Muschelkalk and Kuiper. Later on, they were named as Lower Triassic, Middle Triassic and Upper Triassic. So, these times they are named after the type localities, and these type localities are exposed at different places. But then the isochronous rock or the similar rock and the fossils within those rocks have been identified at different places on the earth. So, that is broadly something which defines Permian everywhere on earth, and it defines Triassic everywhere on earth. But the main problem that comes to our understanding about these extinctions is that we consider Permian Triassic boundary as a particular point in time. Rather, this should be not understood. This is a kind of a misunderstanding. Now, let me tell you why this particular thinking is misunderstanding, when it looks very natural that this particular time defines the boundary between the two domains. Rather, I must say that if the extinction, which is a big event on earth, has to happen, that event happens, it starts at a particular time, at a particular place, propagates to different places of earth with different passing times, and it ends at another place and at another time. By analogy, you can say that if I am to tear a paper apart into two pieces, I cannot tear the two ends of the paper at the same time. I have to start tearing the paper at one point, and then I will propagate, that crack will propagate with time in a particular direction, and that is going to crack the other end at a different time. So, this particular event should not be considered as one point in time, rather it is diachronous. It happened in a crudely defined time zone at different places at different times, and all those times have been divided into a bracket, and that bracket should not be the boundary, rather the bracket should be called as a transition, in my opinion. Permian Triassic transition happens to be the most comfortable and convenient term, and that is the term which embraces the events, and it understands the differentiation that we often observe from one section to the other. Comes a system of rocks. The system of rocks they define a particular rock, particular lithology deposited at a particular basin in a particular place of earth at a particular time. So, it is having its own paleontological constraints, its own fossil assemblage, which may be similar in age with the fossil assemblage deposited elsewhere in the basin at the same time, but at a different place. These is something which is related to the provincialism. So, each region of earth develops its biological forms according to the prevalent ecology. So, it is very difficult to find a particular form exposed in all the sections, and if it is there, that means the paleontological realm was quite bigger. Now, this finishes the introductory part. Then let us talk about the sections and how this boundary is identified. There is an ammonoid, and that ammonoid is called as Otoceras woodwardi. Ammonoids are mollusks, and among the mollusks they belong to the class Cephalopoda. So, ammonoids basically especially concerning the Otoceras woodwardi, this is considered to be a marker of the Permian Triassic boundary, and people consider the Otoceras woodwardi layer or the layer that contains Otoceras woodwardi as the beginning of the Triassic. That means crudely they define Permian Triassic boundary on the basis of the presence of the Otoceras woodwardi. Otoceras became extinct, and this ecological niche emptied by the extincted forms, they are covered by the next group of animals that come. That means the earth's ecological niche is occupied at a given time by a given assemblage, but when by some catastrophe that assemblage dies permanently, so that ecological niche becomes empty and the new set of forms developed at a new time. So, you do get new forms. I will not say that all these forms are new. There are forms that survive that catastrophe and they find their home into the new ecological niche, but there are forms that appear new. There are forms that occupy the older niche and they do not return back. There are forms that returns back, and then there are forms that appear for the first time into the new ecological niche. So, this is how we can differentiate the entire assemblage of the Mesozoic, beginning of the Mesozoic, rather the Triassic, and the end of the Paleozoic, that is Permian. That means Permian time is the time when we see the assemblage which was by some catastrophe happening on the surface of earth, it died and it gave rise to a new assemblage in the Triassic. The problem comes, when are you going to place the boundary at the end of the Permian or the boundary at the beginning of the Triassic? People have different opinions, different places have different classes to identify. Some of them, they regard the end of the Permian, that means the last appearance of the paleontological set that defines Permian, as the Permian Triassic boundary. But elsewhere in the section, we find, that means in other places, we find the beginning of the Triassic. That means when the entire life form, they become vanished and the new forms they appear in the Triassic. That means when the new taxa appears in the section after the Permian forms, they became extinct, that defines the beginning of the Triassic. So, that is something which defines the Permian Triassic boundary in that section. So, that there comes the point of subjectivity, that the last member of the Permian shall be defining the boundary, or the first member of the Triassic should define the boundary, and then which of the forms to be regarded as Permian and which of the forms to be regarded as Triassic is something also which is a new form of subjectivity that comes into the discussion when we try to correlate different sections in terms of the Permian Triassic boundary. Well, so what I talked is that the most characteristic fauna or the forms that defines the Permian Triassic boundary is the Otoceras woodwardi, which later gives way to the Ophiceras. That means one form extincts and the another form takes up. Then there is another group of animals that define the Permian-Triassic boundary, that is the conodonts, and among the conodonts we have Hindiotus parvus. Hindiotus parvus is that particular conodont which is little younger than the Otoceras layer, and it is also considered the best to define the Permian-Triassic boundary layer. In Mishan section we do not get Hindiotus parvus, or we do not get the Otoceras woodwardi, but we have the Permian-Triassic boundaries defined on some other basis. Whereas in other sections of the China, we get the Otoceras layer. In Indian Permian-Triassic boundary sections especially, there are two. The first is the Gour ravine section, that is is in Kashmir, J&K, Jammu and Kashmir. So, Gour ravine section is the Permian-Triassic section, and in this section we have the Otoceras layer, we have the Hindiotus parvus zone, and we have another zone of another group of conodonts, that is Izarcicella izarcica. So, there are three different units that define the Permian-Triassic boundary. As far as the stratigraphic succession is concerned, so it contains two formations, Zevan formation at the base and Khunamu formation at the top. Let us say Zevan formation represents unit D and the overlying Khunamu formation represents unit E. So, this Khunamu, that is the unit E, has been divided into, again subdivided, further divided into three different units, E1, E2 and E3. In the E2 zone, there are different beds. One bed, that is bed number 52, it contains Otoceras woodwardi. Bed number 56, it contains Hindiotus parvus, and bed number 58, that contains the Izarcicella izarcica. That means the bed number 52, 56 and 58, they contains three different forms, of which the basal is the Otoceras woodwardi zone, and then overlain by the Hindiotus parvus, that is further overlain by the Izarcicella izarcica. So, this E1 E2 boundary in the Khunamu formation has been tentatively placed as the Permian-Triassic boundary stratotype section in the world, that is the global stratotype section. What I find is that such specification is very common in the Kashmir section, but if you talk about the Himachal Pradesh or the Spiti Valley section, such wood Otoceras layer is found, but Hindiotus parvus has not yet been confirmed. Izarcicella izarcica also is something which is not that prominent, and Dorashmian is totally absent in Spiti Valley. So, we have the layers, but with the unconformity. So, that is not very sharply that defines the Permian-Triassic boundary. The best section in India is the Gour ravine section. That means, I have told you two major domains, that paleontological domains that are used to define the Permian-Triassic boundary, that is Otoceras woodwardi ammonoids and the Hindiotus parvus conodonts. That means, broadly ammonoid and conodonts have been used in the study of the Permian-Triassic boundary sections. Then comes another, the evidence of the extinction. The causes of the extinction is referred to as the extraterrestrial causes. So, that means some space rock is said to hit the earth's surface, causing such extinctions. Some group of people, group of thoughts, it believes that this particular event has happened because of the change in the chemistry of the ocean, change in the climate. Some say that sea level they reduced. So, if the sea level reduced, epicontinental sea it was withdrawn, and since it withdrew, there are many ecological niche that became exposed to some different situations. So, that those forms they became extinct. Others say that the early Permian time was the time of glaciation, which was followed by in the late Permian time as the warm climate. So, that kind of a climate change was the cause. Others believe that the profuse volcanism in some different specific parts of the earth was the cause of the Permian Triassic boundary mass extinction. So, different people have different opinions. One opinion says that we can see rather the decline of the particular forms at that Permian Triassic junction, but that declines does not define a mass extinction type of an event. It may be the regular course of earth that the organisms, they appear, they grow, and at some time they die. It should not be clubbed with the extraterrestrial causes. But the presence of the buckyballs, that is the Buckminster fullerenes. What is Buckminster fullerenes? It is the kind of different special form of carbon. The carbon has one end and attaches the other. So, we have polymers of the carbon forming on the earth's surface, but in this space the carbon forms the kind of a football type of a structure, which is called as the Buckminster fullerenes, that is a space molecule. So, when it is found on the earth's surface in the Permian Triassic boundary layers, that means it was brought by the space rock. That means the molecule that exists only in this space, if it is being found in the layers of the Permian Triassic, that defines that gives some indication of the asteroid impact on the earth's surface that causes the extinction of such a big scale. Then comes iridium anomaly. Iridium is a kind of an element that is very rare on the earth's surface. It is found at two places, either much beneath the earth, that means it is inside the earth. So, through volcanism or through some event when the magma come up, so that brings the iridium layer to the top, or if the space rock hits the earth's surface, then the iridium is brought to the surface. Otherwise, the surface composition has very less iridium, very insignificant iridium. So, when we get the iridium anomaly at the Permian Triassic boundary, that also gives an indication of either volcanic event or the extraterrestrial event. Negative excursion of the delta 13 is also one proxy that defines the biomass which is created by the death of a big population of the animals or the flora and fauna. There are many factors, there are many things to constrain, but as far as the terrestrial, whatever I have talked is the marine forms, marine animals. But let us try to discuss what happens of this event, what is the consequences of these events on the terrestrial forms. In the terrestrial forms, we identify the terrestrial biosphere at that time by the presence of the plant fossils. Terrestrial fauna was very rare at that time. There are, that is Listosaurus, and then some tetrapods were there, but there are very few, not exposed everywhere. But the plant fossils, especially the plant microfossils or the pollen and spores, they give you a lot of indication. But as far as the abundance of this perennofossils or the pollens across this Permian Triassic boundary is concerned, then we see that there is no effect of such a mass extinction on the terrestrial forms. That means, mostly it affected the marine rhea. The most characteristic pollen of the Permian Triassic transition is the striated bisaccate pollens. So, when you get the striated bisaccate pollens like Denzi's, Sporites, and there are many others, not to take their names, they are unnecessary. To be very clear cut and correlating on these two grounds, it is said that the terrestrial forms, it remained continuous, no significant decline is seen across this transition in the terrestrial flora and fauna, but there is a significant decline at the at the end of the Permian, and till some time these forms, they became extinct for no time to come, and then the beginning of the Triassic brings you with the new life forms. Some of them are common, well the others, they have their first appearance, they appear on the Earth's ecosystem for the first time by the ecosystem niche which was emptied by that big catastrophical event, and it is joined by the new evolution of the life forms. As far as possible, I have tried to combine all these things together in much of the organized way as best as I could. But I understand, since the understanding, human understanding, our understanding about the Permian Triassic mass extinction itself is disorganized, whosoever tries to organize itself would lead to a disorganized discussion onto that. Anyway, we will be discussing about the more special and interesting features in the lectures to come. Till then, thank you so much.